Hello and welcome into my workshop. Of course, like many others of you, I think over the entire world, we're in complete lockdown now. So in an effort to, I suppose, entertain you and keep a lot of you from getting cabin fever, I hope to put out some videos, possibly shorter videos than I have been doing, to entertain you a bit. I'm not going to comment on what is happening around the world now. I think it's been publicised enough, and we're all in the same boat. So I suppose we all cope with it as best we can. Over the next few videos I'm going to be doing a job on my laser. Actually, I'm going to turbocharge the filtration system. It's always been adequate because I run my laser with the the door open, so I can film in there. Some of the gases and smoke does come out through, so I want to completely stop that. So to do that, I have to improve the airflow. On the more modern carbon filters that are supplied with lasers today, they have a built-in pump, suction pump, air pump inside them, as well as assisted by the general exhaust fan on a laser. So what I'm going to do, I have this mains voltage fan, which is quite a powerful fan, and I'm actually going to mount this in the top section of the filtration system. So and to do this process, I'm going to be using the CNC router and the laser to do some cutting and what have you. Probably more on the CNC router, but throughout these videos I'm going to be using quite a number of the programs associated with these machines, like Laser Cut with the laser, Carveco Maker, probably Maker Plus, and I'll be using the CNC router with Mark III. So several different programs and several different machines to do this conversion. So I think what I'm going to do now is I'm going to demonstrate what the problem is, make a bit of smoke, so I can show you what's happening, and we'll compare it at the very end of this series of videos. So before we go and start up the laser, I'll just show you a very quick demonstration of using Laser Cut. So what I'm going to do is go up here and pick a drawing tool, which is just a square, and it doesn't matter where you put it on here. This represents the table area of my laser, but I'm not actually worried about the start of the program or anything like that, because I will set the 00 on the job, and I'll show you what I mean by that in a minute. So simply just draw a square, come here, and we'll make it a measured size. So unlock the aspect ratio, and let's say we want 20 by 20 millimeters, which is just a shade over 3/4 of an inch. 3/4 of an inch is 19 millimeters, by the way. Do you know what? We will make it 19 millimeters. So that's now 3/4 of an inch. And then we're going to come up here and alter this from a cut to an engrave. Now, if I double click this now, it'll bring up this dialog box and I can set the parameters of the laser. Now, because I want to create smoke, so I want some burning, you know, more burning created than normal because I want to create some smoke, I'm going to drop this speed down to 200, but I'll leave the power setting the same, which will give us more smoke and burning, which we don't normally want, but in this case we do. And that's it. Very simple program. It's written, and I'll just send it to the laser now. Okay, this is the computer that's connected directly to the laser. So I'll show you how to transfer a program into the laser. Okay, so you can just come down here in this bottom corner. It says download, download current file, which is exactly what we want, and OK. And it's done. Now, to move the laser around, OK, you've got to make sure that this box here is not highlighted, or there's nothing highlighted here. Then that allows you to move it around, like so. And okay, so that's it. You know, you can see that. Okay, so now what I'm going to do, I am going to tell the laser that the program that I've just uploaded into its memory, now where this pointer is at the moment, where the nozzle is, I'm going to tell the laser, well, this is your point of origin, your 0, 0 position, and start of that little program. So all you do is press once, twice, set the origin, and the program then is locked in, and the laser knows exactly that's the start of the program. Now, what you normally do then, you would run the test. Now, if you watch the nozzle as well, it'll just run around where the program is going to lie. Test. There you go. So now we press start and the laser will start, but I want to move the camera to show you what's happening with the smoke. You know, I regard it as a little bit asthmatic, shall we say, this system. So I'll just move the camera now so it gives you a better view. Okay, let's start. See if I can get this right. Okay, you can see that the smoke is coming out through the sides, and it's coming out through over here slightly. I mean, a lot of it is curling back over and going out through over there. Now where it should do, it should go out through over there. You can see the smoke is curling and going over. So my aim is to greatly improve that situation. With the door down, obviously the problem goes away. And you can still see with the door down, you might be able to pick the smoke up. It's a bit leisurely, a bit asthmatic. So that's the position, so that is what I want to improve. You can see it is actually going down in over there. Okay, so that's what we want to improve. So where I'm going to put that fan is in the top section or the top plenum of that carbon filter. So that means I've got to strip it down, at least pull the laser out and get in and undo that top section. So it's only the top section I'm actually going to be working on. So we're going to do that right now. Okay, so here's the top plenum. So what I need to do is, well, I have to build it inside here because there's a paper filter just below here. So what I need to do is position this fan totally inside there like that. But I'm going to cut a hole that these fan blades just fit in. I'm going to make it out of 3/4 inch plyboard. And I thought this piece was going to fit, but it's just slightly too small. So I'm going to have to cut some out of a bigger sheet. But the idea is that I sort of put it in there like that, put this side, allow this side to drop in, and then pull it back slightly. And just allow, I can put a couple of screws, one sort of here, just cut 4 screws, because the sealing part of it is out on the outside edge out here. So I'm not going to interfere there, and I've got a little bit of leeway, a little bit of room. So that's what I'm going to do. But also, obviously, as this is fitted in there like that deep, like that, or not, sort of just that deep, I'm going to have to make a framework up here to hold this motor securely, which is all right. Not too complicated. Okay, so cut a piece of board to go in here first, then we'll put it on the CNC router and cut a hole, and I'll show you in Carveco Maker how to do a simple program and then put it into Mark 3, and we'll cut it. So now I'm going to find the center of the material. So I know the exact spot where I have to set the 0, 0 on the CNC router to cut this circle out. Easy to do, you just go from corner to corner, like so, put a line so, corner to corner, line so, that's the center. Okay, so this is Carveco Maker Plus. Carveco Maker will do this. Incidentally, Carveco is the new name for ArtCAM. So all the ArtCAM tutorials that you see actually apply to this program as well. So what we're going to do is we're going to go up here to this top corner and we're going to say new model. And we're not going to be exact here. I'm just going to say that the model size is 300 by 300 just for rough figures. It's just to give Carveco some material size to work with. And what I'm going to do is I'm going to set the origin, because this little orange marker you can move anywhere around here, and this is where you set, this is where the start of the program is. So you're indicating to Carveco, well, this is where I want you to start. So remember, I put a cross on the right in the middle of the material. Well, that's where I want to start the program. So I set the tool in the middle of the piece of work to locate where I want the start of the program. So you indicate it. So you indicate it here at this point at the very start of writing the program. Press OK. So I'm going to come up here now and select the drawing tool. Now, if you notice, first of all, we'll go into 2D. You can see better. You can switch between 3D and 2D just up here in this top corner. So and you will occasionally notice I slip up and say, when I'm talking about this program, and say ArtCAM. Well, that's because I've used ArtCAM for more than 10 years, and I was introduced to Carveco about 12 months ago. So I sometimes slip up, but it means the same thing because it's exactly the same program. So all the tutorials that you see regarding ArtCAM, it relates to this program as well. Okay, so we've selected the circle drawing tool. I'm going to bring it into the center because that's where I want it to be. If you notice, when this gets to the center, it changes to a target. So Carveco has found the center of the material and it's indicating that to us. So I left click, draw it out, change. I don't normally work in radius, I work in diameter. And I'm going to precisely say I want the diameter, let me see, 205. Okay, so we have our circle now at 205 millimeters, and there's our hole. So the CAD side of it is done. That's the hole we want. Cancel out of that. So then we go to toolpaths. Now you can either go up here to toolpaths and pick it up here. We're doing a 2D toolpath, or you can come over here and pick it from here, which is what I tend to actually do. So we're going to do a simple profile, and we want, so we have this selected, we have our hole selected, so now we have to change this from outside. We don't want to profile the outside, that'll make it too big. We want to profile inside. And so the little diagram changes to an inside profile. Selected vectors, that's fine. This, as we're doing a simple 2D contour, these really don't matter. Start depth 0, because the 0 is going to be the top of our material. Finish depth, yes, 18 millimeters, not 19 actually. Tolerance is okay. Profiling tool. Now that is going to, I'm going to actually have to make a tool in here. So I'm going to say the 6mm. And I'm going to, so we're going to add a tool into the tooling list now. So I've selected 6mm because near to the size that I want to make. I'm going to say copy. So then I'm going to pick the top one there, which is the copy I've just made, and we're going to edit this copy now. It is an end mill, but it's an 8mm, and here it is here. So this is an 8mm. This is an extended one. Beautiful tool. This one, and this one's a carbide cutter, so it'll stay sharp a long time. So 8mm, and let's see, what other information do we need here? Really, the tool number doesn't really matter to us. The units are millimeters, the feed rates are millimeters per second. All that doesn't change. Diameter, this changes to 8mm. So this can be altered when we're writing the program. That's okay. Step over, so this can all wait until we got it into the program. So I'm going to say OK. So there it is there, it's in our system now. I'm going to select it. And there it is there, it's in. So now we can alter the settings. Step over, it doesn't matter, we're not actually doing a step over. Step down, 2.5mm. That's okay. Actually, probably do a little bit more than that. Probably do probably do 4mm. Well, we do 3.5mm. 3.5mm. Feed rate 15. That can go to 25. And plunge rate of 5mm. That's okay. Speed, I like to run this one quite fast. That's 18,000 RPM. And you will learn the speed and feet, through running the tools yourself. Is it burning a little bit too much? Well, the RPM's too high. Now you can do two things. You can either lower the RPM down, or you can feed rate up. That will stop the burning. We need to add ramp moves. We want to ramp down into the material. I don't want to lead in. Lead in, we'd have a start in here, then sideways. We don't want that. We want to come straight in this direction and lead in. That's okay. I normally leave these standard. That's okay. This is okay. This is okay. Let's set the material up. Safe 10. Yep, that's okay. Here we go. We're going to say 18mm. 18, so it's going to cut all the way through. Okay. Is there anything else we need? Cut direction, climb milling, that's what I like. No, nothing else. Final pass thickness, no, I want to go all the way through. There's nothing there, it's just a quick cut a hole. we'll add a couple of bridges. Length of the bridges will be 10 millimeters. This is just to hang on to the piece, otherwise, you know, when you come to the last bit of the last cut round, it could start to move around and, you know, sort of get caught in the tool or spit out and snap or do something. So, you know, it's always handy to have some bridges just to hold it there, and you can just cut it through then with a knife even. So I'm going to say the bridge length 10 millimeters, bridge thickness I'm going to say 2 millimeters. That's normally enough. Do we want a 3D bridge? Not really necessary. Add the bridge on a start position. Yeah, you know, I think I'll do that. And that's fine. You know, there's no need to, you know, Carveco has actually selected the best area to put bridges. That's fine. So we're going to go here to 205 millimeter. I just name it, you know, what I can quickly recognize, okay, when I'm sort of putting it into Mark 3. That's good enough. And normally I'll put the 8 millimeter end mill. So we're going to calculate that. That's done. So we can cross out of that, and we can go into 3D, our 3D view, and we can have a look at that. We'll simulate that. To go to simulate, there's a simulator here. Simulator controls, simulate toolpath, go, standards fine, go, boom, done. Okay, so the next thing to do now is to save that little program onto a removable device. Now, I have a lot of people sort of write and ask me how to write G-code. You don't have to. That's what this program does. It writes the G-code for you. You don't have to know anything really about G-code. So here we go. Saving the G-code. Okay, so just go here now to the little symbol for, it's actually 3.5 floppy disk. Now, a lot of you out there probably won't even know what a 3.5 floppy disk is. It's how we used to save files many years ago. Okay. So there it is there, and we want to save it in. Let me see. Storage L, yeah, that's right. That's exactly where you want to go with it. And we will label that 205 millimeter via the 8 millimeter E mill. You just got to abbreviate it. I abbreviate everything. As long as I can recognize what it is, you know, it's fine. Next thing to look for Now, all CNC machines, whether it be a lathe, a milling mill, as in a metal milling mill like a Tormac, or doesn't matter what machine it is, even a Mazak, okay, or a Haas, they all understand standard G-code. Now, standard G-code is G-code millimeter tap. Okay, that's metric. Now, if you was doing this in imperial, in inches, it would be, let me see, here it is here. This one, G-code inch tap. Okay. So you haven't, you know, your machine doesn't have to be in that listing. This is standard G-code. So that's what we're saving it in. Save. And that's done. To verify that, we'll have a look, and there it is there. And indeed it is in, it's a tap file, and it's 22 kilobyte. Very short program, really. Okay, so we can get out of that, cancel that, and now we'll go to the CNC router and put it into Mach 3. Mach 3 is the program which runs the CNC router. Okay, so on my CNC router bed, I've just got a piece of waste material, or could be called a waste bed. This could be called a waste sheet, which it is. So what I've got is a line drawn on here, which is actually parallel with the actual bed itself. So just line this one edge up with that line, and just simply put some wood screws . So what you must do before you start your CNC router up is have Mach 3 up and running, okay, and connected to the control card inside the machine, and then you start it up. So the next job we're going to do is bring this router head or spindle up to the near center here, and we're going to register or make the work offset. So I have a fairly pointy tool in here so we can see quite easily. Now you can move this head around, or the gantry around, by using the arrow keys on the keyboard, but I much prefer, it's easier for me to use a radio pendant. So you just select the direction you wish to go, which is Y in this case, and the speed in which you need to get there by using these two buttons, and then just a little bit faster than that maybe. And then the X. Okay, slow things down a bit. Bring the Z down. Slow things right up. Very controllable. And if you were considering getting a CNC router, I would suggest you get one of these too, because it makes life very much easier. So go down a little bit. Slow it up. And we'll go back a little bit, which is Y. And we'll go over that way a little bit. And forward a little. A little bit too much. There we go. That'll do. So that's the X and Y coordinate done, and I'll show you in Mark III now how to set that. Okay, so before we actually set the XY coordinate, or the work, what's known as the work offset, we're just going to put the program into Mark III. So we come up here to File, Load G-code, and then select the storage device, and there's our program there. Double click that and it's in. So you'll notice here in this diagram, well, Mark III has actually put it in the last known work position on the table. So we're going to put that right just now. So we know that we've set the head of the router in the correct location. So we are going to press X and Y 0. Now we're going to set up the Z with the automatic Z setting tool. Okay, so before we can set the Z with our automatic tool setting device, we need to change the tool and put the correct tool in. So to change tool in this spindle requires just 2 spanners like this. And do the chuck. Take that tool out. We actually need to change the collet. This is a 20 collet. Give it a good clean out. As you change the insert, okay? So we get the correct insert. Okay, so this is the correct insert for this size. You just pop him in there. No need to have too much sticking out. I mean, this is an extended tool for doing really deep cuts. This is fine. Don't do it up too tight, just nice and firm like that, not too tight. I'm going to fetch this down manually a little bit first. Otherwise we'll be waiting a long time. A little bit more. Okay, I'll zoom you in so you can see what's going on. So now all we're going to do is press start and let it cut this out. Now incidentally, I've got Mark III set at about 30% of the feed rate. I just like to see everything's going okay first, and then I'll speed it up to normal range. So here we go. So this is the ramp in. I'm going to speed it up now so I see everything's going okay. Okay. And there is a circle nearly cut right out, so just gotta get a Stanley knife now. Oh, well, there you go. It's out. And we'll hang on to that piece because I think that piece is going to come in handy further on in the project. So I'll just go and clean this up a minute, but oh, I can see that's a beautiful cut. I'll bring this up to the camera, I hope it can pick it up. See how clean a cut this is. I mean, this is a little bit frayed, it didn't quite go all the way through there. And it had a couple of tabs, but you see where it's cut there? Smooth as silk. Beautiful. Beautiful. There you go. So there's that 5mm gap. Fits in there perfectly. Okay, so for this first video, I think that's enough. We will continue with this project using other tools in my shop and hopefully keeping you all entertained. A little bit anyway. So in the next video we'll be using Carveco again, and we will be constructing the clamping mechanism for the motor. Okay, something to hold the motor around here and hold it in the right position in this hole, and you know, in the right location. And we're going to have some sort of adjustment as well, I think, to you know, make it a good sealing project. So thank you for joining me, and it's bye for now.